So 5b, what we're looking for is we're looking for powers of 3 because we're looking to undo this power, this root 3 here. That power 2 over 3, that means power 2 root 3. And so cube roots we can undo with that. We can undo cubes with that cube root. So that's what I'm going to do then. I'm going to express these as powers of 3 if I can. So 8 is 2 to the power of 3. X to the power 6, well, that is, we can do groups of powers of 3, so we can say negative 2. In fact, we can put that in the denominator. We know that's negative 2 cubed. So that cube will undo, and we're going to be left with power negative 2. We can also divide. We can multiply that exponent and divide by 3, which is going to get rid of that, the cube root as well. So there's a few different perspectives we can take on this. This is going to be 3 to the power y cubed cubed. So one of those cubes is going to be ungrouped out of there or divided. And again, same as doing 9 divided by 3 and undo part of that power. In the denominator, we're going to end up with 7 to the power 3. So we have a whole bunch of root 3's in there. Okay, so we end up with 2 over 3. So all these, this root 3 will undo this cube, this cube, this cube, this cube. So what we end up with then, and it has to be to every term, so we are going to end up with 2 x to the negative 2 y cubed, and then 7, and then we apply the square onto that. So we've undone the cube root, we're just left with the square, and undoing this square we can end up with 4. This x goes in the denominator, so it becomes x to the power of 4. We have a 7 in the denominator, and the y cubed becomes y to the power 6. Okay, so we can think of the rule for power to powers multiplication is because we are grouping them. Grouping means, multiplication means grouping, so we're counting by groups. And this is why we can use that multiplication rule for power to power.